I'm Basuri, and today we are starting our crash course on vector and 3D. So we are actually going to start with the vector part at first and then go to the 3D and geometry part. So normally I don't have a pre-written document for starting, but today I am doing this because we need to do this preparation for WBJEE in short period of time. So I will just discuss the few important topics and move on to the question answers. And here, as you can see, I have written some documents and I am written some topics, and I will define you as we will go further on this topic. And after this we will do some questions, and I will also give you a sheet. You must know that the most important thing in maths, if you are mainly focusing to WBJEE only, is regular practice with a good concept. And in maths it has more onto the concept practice part. So we have to practice more and more questions. So in the class we will do few questions, but I will give you some of the questions as a PDF, and you must do it, and many of them would be from the previous year. So yeah, you must do it. That's all. Okay, let's start. So here the first thing is we must know about vector is that it is a physical quantity specified by direction and magnitude. Okay, so it is a physical quantity, you must know it, and it is specified by direction and magnitude. Okay, and you can write a simple vector like this from A to B, where A's point is the tail and B's point is the head. Okay, so it is normally denoted as AB vector like this. Okay, a simple arrow on this. Generally we write a line segment as this, but when it becomes an vector we write it as AB vector, arrow on it. Okay, so mainly we need to know that it must have a direction and also a magnitude. See, here it is having a direction, and the magnitude of any vector is just given by the mod of that vector. By doing the mod we can find the magnitude of that vector. Okay, so there are some laws that it follows. Among them it is triangular law of addition and parallelogram vector law. Okay, so in this one, triangular law of addition basically shows as this, like this. Three vectors would be there. So if this is vector A, this is vector B, and this is vector C, it must be that C is equal to vector A plus vector B. Okay, so this is just the law of the triangular law of addition. For any such vectors you can do it. Similarly, it must be a clockwise, in a clockwise direction or in an anti-clockwise direction. Now suppose we are having this arrow A in exactly the opposite direction, then how we will write it? We will opposite it as minus A. If AB is this one, then this one is, this is B and this is A, suppose. So this is minus AB. Okay, so exactly we will just opposite it, and we will get it as a clockwise or anti-clockwise direction, and then we can use this formula, or sorry, we can use this law. Okay, so now the parallelogram vector law states something like this. I'm not defining it properly right now, but I'm just showing it. Okay, let this is A and this is B, then and this is C. The C is equal to A plus B. Okay, this A and this B will give a resultant as C, which will fall as the diagonal of this parallelogram. This is the parallelogram vector law. Sorry for the mispronunciation. So I have just told you in a very basic way. I think you can get it. Okay. Oh yes, if also anyone has any language problem with this and want me to say in Hindi, please inform me in the Telegram group or maybe in the comment section. Okay, so now let's move forward to the different types of vector. This is just the basic types. Okay, so the free vector is this one, just 2 points and one as a tail, one head. Nothing more to know about it. And the null vector is where the magnitude is 0 and it does not have any definite direction. I mean, this dot is a null vector. Its magnitude is 0 and obviously it does not have any direction. A null vector cannot have a direction. Okay, so now the next one is this one is done, this one is also done. Unit vector. Okay, so for unit vector, the magnitude is 1. Okay, so this one mod of AB, it would be equal to 1, that is unit vector, and the direction may be anything. And the equal vector is we know that vector is that physical quantity which has direction and magnitude. So a vector whose direction and magnitude both are same are called equal vectors. Both must be same. And this one we get as parallel vector, and parallel vector are those whose directions are parallel to each other. That means the cross product would be 0. Okay, we will learn that what is cross product. You may have learned it in the physics part, but we will also get a summary on it. And then we come to coplanar vectors. Coplanar vectors are mainly those which are on the same plane. Okay, those which are in the same plane. Here we also had that collinear. Okay, collinear means at the same line. Those are also parallel and also collinear. Okay, so a vector like this maybe. Here is A, this is B, and again from here to here C and D. Okay, so this is antiparallel, but not this one. Let be this from AB to this one CD. Okay, so these are here collinear as well as parallel vectors. And if we just shift this CD, suppose here CD, and suppose these two are parallel to each other, then this will be said as the parallel vector. And coplanar vectors are lying on the same plane. I mean, you can say that any vector I have drawn on this copy are coplanar because this copy is a plane. Okay, so all the vectors drawn on this copy are coplanar. I mean, this CD, this AB, this AB, this one, these all are coplanar. Okay, so now let's move on to these are some basic things. Okay, you must know a little bit about it at least. A direct question comes from this null vector and unit vector, that prove that this is a null vector or prove that this is a unit vector. This must be known. Now we are coming to the position vector of a point P. For any point P, let P, here it is, let it be x comma y comma z. Okay, so now this is point O. So OP, if it is a vector, it will give us the position vector. O is the origin, that is 0 comma 0 comma 0. Okay, so OP would give us the position vector here, xi cap plus yj cap plus zk cap, and its magnitude OP is equal to under root x square plus y square plus z square. This one, the mod one, gives us a magnitude as this. Okay, so now we are going for this one. So you got it right. For any point P, x, y, z, we can find the position vector as this. And this one, yeah, for this one, scalar components of vectors are its direction ratios representing its projections. Okay, so here in simple language, if you see this xi cap here, x is the scalar product of OP with x-axis. Okay, I mean the projection. If this line, if you may say if a shadow, if a sunlight is fallen exactly on P, on the line OP and x as the parallel, if we see from the upper side, let this is be OP, and similarly this is the x-axis. Okay, in such condition, if we throw light on this in a perpendicular direction like this, okay, then we will get a shadow here. This length would give us the x. This is the projection of OP on the x-axis. You may just see it like this also. When you will see the vector OP in this way on any axis, like on x-axis you are seeing it, if you see on the y-axis, similarly this will give us the projection on that axis. Here it is x, for y it will be y, and z it will be z. These parts are the projections. Okay, and then we come to this one. Yeah, okay, internal division and external divisions. This is quite an important topic and you must know about it. Let this okay, let this be from this to this. Okay, so we are internally dividing it as m is to n. Now if we yeah, this point has a vector. Okay, this is a vector, let it be a vector, and let this be a b vector, this point. Okay, so now we need to find a vector, let it be p vector we want to find. So now this p vector would be found out as like this, m into b vector plus n into a vector, okay, m plus n. Like this we can find out the position vector of this p. Okay, similarly if this is outside, this point p is outside this one like this, then we will do as a negative one. Similarly the ratio would be m is to n only, but we will do it as the minus. Okay, so this is the internal and external division. Let me show one external division also, otherwise it may be a bit confusing. Okay, so for external division we are taking this one maybe. This one is a vector, this one is b vector, oh, this one has A vector. Okay, so this is the AB vector we are talking about, and at this point we need to find the position vector of point P. We are having these two. Okay, for these cases we are using the external division, where this whole part is M and this part is N. Okay, in this ratio M is to N, it is, this line is divided as M is to N. If this is M, then this is N. Okay, so now we are just multiplying M into B here and N into A. Okay, similarly we are also dividing this term as M by M minus N by M minus N. So we are getting this one for external division and this one for internal division. So I think you got it. This must be known that which part we are taking as M and N, otherwise it can be a bit confusing. So I think you got it. So copy this down and we will go to the next page. So let's start the next page. Here we come with the scalar product. Okay, so scalar product is the product of two vectors in such a way where we don't get any direction, we just get the magnitude. Okay, so here you can see that A vector dot B vector gives us as mod of A vector into mod of B vector into cos theta. What is theta? Theta is the angle between these two vectors, right? A and B, this is theta. Okay, you must take that acute angle and not the other angles. I mean, you should not take this one, not this one must be taken. Okay, I mean the smaller one, the smaller angle you get. Okay, so now the cross product. Cross product gives us a direction also, as you can see here. So it is the multiplication of two vectors similarly, but here we get the direction and also the magnitude. The magnitude is this one, A vector modulus into B vector modulus into sin theta, and theta is the same, this one. So we get the both quantities, that is the magnitude as well as the direction. Okay, so next one is the, okay, now we are just taking two vectors, A vector and B vector. So A vector is A1 I cap plus A2 j cap plus A3 k cap. B vector is B1 I cap B2 j cap plus B3 k cap. Okay, so now if we add these two vectors, we will add it as A1 plus B1 whole I cap. I mean this, the term with the I cap, and here also the term with the I cap will get added. No such term will have to be added in this part, and similarly the part with the j cap, I mean you are adding the vectors, the directions. This I cap and j cap, k cap, what they means? They means as the directions we know. Okay, this is suppose x axis, this is y axis, this is z axis. So this x axis gives us the I cap direction. Any vector, any unit vector, I cap is a unit vector along the x axis. Okay, I cap is a unit vector along x axis, j cap is a unit vector along y axis, and k cap is a unit vector along z axis. Okay, and also one more important thing is that you must know that for this cross product, if you multiply, I mean this must be known. Okay, I, j and k, this goes like this. Okay, now if you multiply I vector into I cap into j cap, okay, I cap into j cap, it will give us as k cap. Okay, this one into this one is equal to this one. Similarly this one into this one, that is j vector into k vector, gives us as I vector. Okay, now we are left with k vector into I vector gives us as j vector. Now suppose we are going in the opposite direction, that is, this is the clockwise direction. We will now go in the anti-clockwise direction. Now if we multiply it as the opposite one, just j cap into I cap, this will give us as minus k cap. The anti-clockwise turning here will give us as any negative. So this one is just a shortcut. You must note it down. It helped me very much. I am sure that it will also help you in your studies and finding any cross product in this way. Okay. Well, now you can also think that why it is coming negative. It is just that we are taking in everything opposite in the terms of direction. Here we are multiplying the I at later one and j as the before one, so we are just reversing the direction of the vector. That's why we are getting here minus. Okay, so this is also one of the topics in the cross product, and as I told you that you can't learn the vector part as so fast, but we will go through the questions and you will learn through the questions many of the concepts. That would be quite faster and would be on the topic you are focusing on, so it will be quite easy for you and me both. Not me, sorry. For me it will be quite hard, but still it will be fruitful for you. So now we are coming to this one as lambda a, any constant multiplied to one vector a, where a is this one. It will give us as lambda a1 I cap plus lambda a2 j cap plus lambda a3 k cap. Simply we are saying that we can multiply this constant with I caps constant separately and j caps constant separately and k caps constant separately. Okay, we can separately multiply it. Okay, so as this is just a number, not a it does not have a direction, so it is not a vector. Okay, it just has the magnitude. And similarly, any scalar product, if we get, then we can add it with the cross product like this. You will learn it later. I will not confuse you with it. And now this one, a vector into b vector, the cross product, a cross b, we say it as a cross b. Okay, so here we do the cross product in this form. We also have some other forms, but you must learn this one for now, and when we will learn this chapter in depth, we will go through the other processes. And for this, I think you know it already, that how to solve this determinant, that I cap into a2 into b3 minus b2 into a3. It is just a formula. If you don't know, then I am writing it. Just this is the I part. I just left it down for you, that j into, okay, this one is minus, sorry, minus j into a1 b3 minus a3 b1 plus k into a1 b2 minus b1 a2. Okay, so this is the formula. You just remember it for now. You can just put it to find any cross products. Okay, so and this is the distance between any two vectors. Suppose a and b are the two vectors here. So here like this, we will we'll take the part with I cap and just subtract it. You can subtract a1 minus b2 b1 also and b1 minus a1 also. It will give the same answer because we are just squaring it, so the negative sign would just cut out. And here we are squaring it, then we are adding such terms like this and giving a square root to it. So this is it for the formula part. I think you get it, and if you don't get it, don't get hesitated. We will learn it later on, but for now you must remember some of the formulas. If you can't get it, if you have any problem, you can ask it in the Telegram group. And now we are going to do 3 questions on it, and I think it will be quite hectic for you, but we don't have much time, so yeah, we have to do it. Okay, for suppose this is a question from the previous years, and it is for non-zero vectors a vector and b vector. We have these equations, then a and b are. So I will say to pause the screen and try it by yourself for once. Okay, I think you have done it. So now I am solving it. Please be fair to it that you have done it, or at least tried it. Okay, because the approach of doing any questions in JEE is the most important thing. Okay, so let's start it. And the equation is this one. Okay, so we will just square it on both sides. This is the solution part. So then what we get? See, it is mod, so if we just square it also, the inequality will not change. Okay, so you should keep that in mind also. If we just square it, see, a vector plus b vector, it would be as a square plus b square plus 2a vector dot b vector, that is less than a square plus b square minus 2a vector dot b vector. Okay, now why and how we just converted from this to this, that is quite a thing, and you must understand it. So it is also a formula where we have a vector plus b vector is equal to a vector under root a square plus b square plus 2 mod a mod b cos theta. Okay, now you can see that we just use this formula and converted it from this to this. Okay, now we are using the same here also, just this is the play of addition and subtraction. And now then we get from here, we get this got cut, and yeah, 4a dot b is less than 0. So see, the mod of a and b can't be 0 there, and 4 is a positive number. Therefore cos theta is less than 0. That is, theta is an obtuse angle. Okay, you may have one problem, I think, here, because here I said once that it would be acute, but no, it can't. It can be obtuse also. We just have to take the smaller angle. Okay, it can be like this also. This is an obtuse angle. The acute angle is just less than 90, but it can be obtuse. But see, here also we get two angles, the bigger one and the smaller. We must take the smaller one. Okay, so theta is an obtuse angle here, as we get cos theta is less than 0. So it is collinear, no. Perpendicular to each other, no. Inclined at a right angle, no. Inclined at obtuse angle, yeah. Inclined means it is at an angle to that. Okay, so these are the vectors here. Okay, so let's move on to the next question. You may copy this down. Yeah, obviously you must copy this down, because a note in maths is really important at the last minute revision and the practice part. Okay, you face any problem, this is kind of short note till here it is kind of short note, you must note it down, and each and every questions have a uniqueness in it. If we are doing it in a short period of time, we will have some concept like this. This is just a simple property which you must know for any physics vector calculations or any other vector calculations. Okay, similarly we will learn few more things also. In between the questions you must write down the questions so that you can keep a grip on them. Okay, so copy it down and let's move forward. So here we are with our second question, and here we will at first read the question properly. That is, if 4 points with the position vector this and this are coplanar, then find the value of lambda. So we have to find lambda here. Okay, so let's say here A is minus 2 I cap plus j cap plus k cap. Okay, B is vector is I cap plus j cap plus k cap. C vector is j cap minus k cap, and D vector is lambda j cap plus k cap. Okay, now you will say that why I just wrote these down, this might not be written also, but a representation of data can have a great effect on your brain, you know. So you must write this down properly so that you can think over it much coordinatively. Otherwise you brain just get distracted. Here these things are not needed, you know, these words, these letters are not needed. Once you get to know the understanding of the question. Okay, so at that time you just need these vectors. Now these vectors are also not needed, you just are considering with A, B, C and D. We are just making the things much more comfortable with us. Okay, so now let's start with it. And here, you know, for these vectors are just like this, and this is point O, maybe this is A vector, this is B vector. Suppose I'm saying this is C vector and this is D vector. From O to A we get OA. This OA vector is same as that A vector. Okay, this is O. OA vector is same as that A vector, and that is this one. Okay, so that vector would give us a line, and this OB is same as that B vector. Now if we join this one like this, see, this is OA, this is OB. Now from A to B if we join, then you can see that this AB, oh, let's say, yeah, this OB, sorry, OB, this OB is equal to OA plus AB. Now AB is equal to OBs can be written as B also. No, O can be written as O, only A also. Okay, okay, we are just writing one more step for that, no confusion would be there. So AB is B minus A. So like that we are getting a line here, in which both these points are in the 4 points consisting here. Okay, if 4 points with position vector this are coplanar, so these both points are coplanar. We are getting this line similarly. Okay, so now we will similarly find out the other two lines. We are getting two line means this one and this one, any two lines we need that must conclude that lambda term. Okay, because we are just finding out the value of lambda only. So let's say we are taking C minus B, C vector minus B vector, maybe that would give us as minus I cap minus 2k cap, and yeah, this one we just did not find out only. This would be plus 3 I cap. Okay, and the other one would be D minus C, maybe that would give us as lambda minus 1 J cap plus 2k cap. Okay, so now for proving the coplanarity of these 4 points, we will have the determinant do its work. Okay, so it is quite a thing that why we are using the determinant here. So see, for using determinant means we are doing the cross product of those two. Okay, so let's say we are not doing determinants, can't understand it at the first time. We are doing a scalar product of this one and this one. Okay, we will do the scalar product of this one and this one, then we will do a cross product, a scalar product again with this one, and the term must be 0 because see, this both lie in the same plane, suppose. Okay, so these two, if we do a cross product, it will give us a third vector that is totally perpendicular to the plane, that is like here. Okay, if we draw it, then it will look as out of the plane. So this is the perpendicular vector. Now we get it when we cross these two vectors. We can find out the direction of this one by doing the right hand thumb rule. Okay, from the vector, this vector we are turning to that vector, maybe let it the A vector, this is B vector, so A cross B, let's suppose C, this is C. Okay, so A cross B gives us the upward direction, so this is a C vector in the upward direction. Okay, so A cross B gives us a C. Similarly, now if we if we do a cross product of this and this, and then the rest we have the other vector, this one is the first, this one is second, this one is third. We got 3 lines, right? 1 2 3 3 lines we got. Now we have done the cross product of 1 and 2. This is 1, this is 2, this is 3. Okay, we have done the cross product of these two, and then we are doing the scalar product of this one and this one, C and 3. Okay, if we are doing the scalar product of these two, then cos 90 mod of C vector into 3 vector, this is just the naming one, okay, into cos 90, this value is 0, so this must be equal to 0. Okay, now we are solving it. You will get it now, don't worry. I know it is a bit confusing, but yeah, now you will get it surely. Okay, so here we have this one and this one. We are doing a cross product here. Okay, so I cap, j cap, k cap, minus 1, minus 2, sorry, 0, and here minus 2, and here we have 0, lambda minus 1 and 2. We are doing the cross product, and by doing the cross product we are getting it as I cap, this 2 multiplied, minus 2, and then again minus, this is 0, sorry, not 0, minus of minus 2, that is plus 2 into lambda minus 1, okay, minus j cap, this is I cap, this is j cap, now minus 2, and this is 0, plus k cap, that is minus lambda plus 1, and this is 0, minus lambda plus 1. Okay, so from here we get it as, you must solve it by yourself, don't just copy it down. Okay, so we get it as 2 lambda minus 2 minus 4, sorry, I cap, and plus 2 j cap, and minus lambda plus 1 minus of lambda, and we are taking the minus common, k cap. Okay, so from here we are getting it as like this, and now we will do a dot product with this one, and in the dot product we can see we just have this I part, so we will just multiply this one and this one. The other parts are 0, so it will be 0. So now here we multiply 3 into 2 lambda minus 4 is equal to 0, that is 2 lambda minus 4 is equal to 0, that is lambda is equal to 2. So the value of lambda is 2. I think you understood that I cap into I cap is 1, but any other I cap dot I cap, we are doing here the scalar product, scalar. Okay, we are doing the scalar product here, so I cap into scalar product with 3 I cap here would give us 1, and similarly with j cap and k cap it will be 0, because the cos 90 would be there for those two parts. Okay, and I guess you are clear with that why we are taking this whole term, and by doing first doing the cross product and then doing the dot product as a 0. I think you are clear with it. So I also want to say one more thing, that here is a shortcut to it, you know. Suppose say we have taken here a vector, b vector and c vectors. These are the lines, suppose. Okay, so now a vector into b vector, this is the cross product dot c vector. Then we are doing the scalar. We just did this one, right? So this can be represented as this one: a1, a2, a3, b1, b2, b3, and c1, c2, c3. Okay, now just calculating this determinant, we can find the value, which would be 0. We can find the value of lambda here. Okay, like this. Here for this case it will be 0. For any other case it can be anything. Okay, so I am just saying that you can represent this one in this form, where a1, a2, a3 are the parts of a vector. Okay, and also here this is just a shortcut method, you can say. It is just found out through the outcomes, but main thing is this one. You must understand this. Now I'm not doing it again in a fair copy or something. I want to let you understand this question and do it by yourself. Don't just copy it down. You can see that you can't just copy this thing down. You can't get it at any point. So follow the video, understand it, and then do it by yourself. Okay, so now let's move to our next question. Before that, I want to say that I just kept one thing in the triangular law, so let's go into it. So here I missed one thing, that this is not equal to, okay, the summation of a plus b plus c is equal to 0. This one is 0. For any a plus b plus c, it will be 0. Not that c is equal to a plus b. No, a plus b plus c is equal to 0 at all times. Similarly goes for the anti-clockwise. For any you may think it as that minus c minus a minus b is equal to 0. Taking minus common, it will give us the same formula or law. Okay, so these vectors as in the same clockwise or anti-clockwise direction, when added gives us the resultant as 0. So a vector plus b vector plus c vector is equal to 0, and here is the parallelogram vector law. Okay, so parallelogram vector law and triangular law of addition is quite important. I just missed this part, I don't know how, but while seeing the video I just remembered and thought to take a look into it. So I think you get it. Now let's move to the last question. So here we are with our last question. The last question is that if a, b, c are unit vectors. What is unit vector? Unit vector is which mod gives us 1. Then a minus b whole square plus a minus b minus c whole square plus c minus a whole square does not exceed, that is the value of this one, it is a minus b whole square plus b minus c whole square plus c minus a whole square less than equal to k. So k is equal to what? We must find out this. Just simplifying it in the mathematical terms. Okay, so here for finding it you must use some algebra. Okay, so by using algebra we can say that just querying these terms, as we know that by the previous formula we saw that for addition of two vectors or subtraction of two vectors, by using that formula we will just expand it as a square plus b square minus 2ab cos theta or minus 2 a dot b, and similarly for this one and this one. So for any mod of these vectors we have unit vectors. Similarly we will have a vectors plus b vector plus here also b vector plus c vector. So just 2 times of each unit vectors, that is 1 square, minus of 2 into a dot b plus b dot c plus c dot a. That is I think I did something wrong, So it is 3 into 2 into 3 times, so it is 6 minus 2 into a dot b vectors. Here it would be okay, let's think on this one. That so see, here we can use the formula that a plus b plus c whole square is equal to a square plus b square plus c square minus 2 into ab plus bc plus c. That formula we can use for vector also. So we are just using that algebraical formula here, and we are just transforming it into this one, a plus b plus c whole square minus a square plus b square minus a square minus b square minus c square. Okay, now this one, just taking the minus common here, a square plus b square plus c square. What is it? You say that what this thing is, the square of a unit vector, the square of a unit vector, the square of a unit vectors, that is 1 1 and 1. So 1 into 3 gives us 3. So this 3, here we have minus, this also minus, so minus into minus gives us plus. So 6 plus 3 minus a plus b plus c whole square, that is 9 minus something positive. This must be something positive because we have a square, and so here we were calculating k, right? We are calculating k. So this is the term. So this term, this whole term must be less than 9, less than or equal to 9. So the k is 9 here. The correct option is this one. Okay, so here we are ending our session today, and for the next one we will do some more questions on it, or maybe we can start the coordinate part of the 3D coordinate. That is quite very important, and so let's see what we do. We are ending it here now. If you have any doubt in this or the questions I am going to send you, please contact me through Telegram, and best of luck.